Okay guys, in this lecture I just want to talk about charge a little bit. It can be useful to have a good idea about kind of the typical amount of charge for everyday phenomena, for normal objects. This helps you realize whether or not the solutions you're getting to homework, for example, are reasonable. Okay, so I talked about in the last video on units that the standard unit of charge in our SI unit system is called the Coulomb. Okay, abbreviated with C. And the charge, kind of the fundamental quantized charge, okay, that's actually pretty important. Charge is quantized, which basically means you don't have a continuous range of charge that an object can have, because charge is derived from the balance of protons and electrons in an atom. A charge can only be different by the charge of a single electron. So charge is quantized with the smallest unit of that quantization being the charge of an electron. And the charge of an electron it's negative because it's an electron. Okay, charge of an electron and proton are the same. The only thing is different is whether it's negative or positive, and that's 1.6 times 10 to the negative 19 Coulomb. So a really small number of coulombs, okay? And that's kind of important to keep in mind. That's a really small number, so be comfortable with that. Because that's a small number, if you were to charge an object by friction, which is what you typically see in a physics class, but also is like typically how people interact with charge. So for example, if I were to rub my feet along a carpet and generate some static electricity, that would be charging by friction. So most objects that are charged this way, okay, not intentionally charged to a high level, obtain a charge on the order of about microcoulombs. So micro is 10 to the negative 6. Okay, so that would be around 10 to the negative 6 coulombs. Okay, it could be an order of magnitude higher, lower, but that's kind of a typical amount of charge for an everyday object. Okay, just to give you a little bit of a bigger scale for fun, a lightning discharge is moving about 10 coulombs, which really, again, that gives you an idea about how big a single coulomb is. Lightning is moving a whole lot of charge, but 10 coulombs of charge is transferred in a lightning strike. Okay. And then, again, just to give you an idea about what it means to be have a charge of 1 coulomb. 1 coulomb is an incredible amount of charge. So it's kind of fun to look at the force due to two 1 coulomb objects separated by a meter would be about 10 to the 10 newtons. Okay, that's a whole lot of force. Okay, so that gives you an idea about how again, powerful the electromagnetic forces can be, but also how big 1 coulomb of charge would be. And by the way, electromagnetic forces, I think I talked about this in the beginning of the class, they're way stronger than gravity, okay? You get an idea of this if you charge a balloon on your hair. You can stick it to the wall and it might stay there. That means that the charge that you transferred created a strong enough electromagnetic force that it's counteracting the gravitational force that is due to the entire mass of the Earth, okay? So it's a really good thing that our universe ended up being charge neutral. So as astrophysicists think in the beginning of the universe, right, as many positive charges were created as negative charges, and that charge balance has continued. Because if there was not a charge balance in the beginning of the universe, then instead of our whole structure of our universe being determined by gravity, it would have been determined by electromagnetic forces, and it certainly would be a lot different than it is today. Okay, so that's all I wanted to say about charge. Lots more interesting stuff if you guys want to do more research online.